All right, this next video is really going to tie in section 8.1, okay? We're going to talk about phase shifts, vertical shifts, and how everything kind of ties together. So just like we did in 8.1, we can look at tangent with all of these letters. A times the tangent of bx minus c plus d. And before, A was the amplitude, but now it's the stretching factor. Right. Technically, the stretching factor is the absolute value of A because it could be negative. And again, B relates to the period, just like we did in the last video. Right? The period is pi divided by the absolute value of B because tangent normally has a period of pi. So that's why there's a pi on the top. Whereas sine and cosine normally have a period of 2 pi. So that's where there's a 2 pi on top in that one. And C is just going to be like before. C over B is the phase shift to the right. So if C is negative, meaning this is positive, then it's going to go to the left. And just like before, D is a vertical shift. Okay, so this is really just combining what we did in the last video, 8.2.1, with the previous section, 8.1 on graphing. All right, so let's do an example, talk more about graphing. Example number 2. Graph 2 periods of y equals -2 times the tangent of pi x plus pi minus 1. All right, Desmos will help, but Desmos is not going to do everything for us here, okay? It's going to be maybe a little tricky. All right, so let's get our graph paper back. Let's grab it over here. And let's type it into Desmos and see what we get. All right, so when we do that, we have a different graph now. We're going to have y equals -2 times tangent of pi x plus pi minus 1. So there's a lot of things happening here. And we have different asymptotes. First things first. Notice that tangent's going down now, right? As we go from left to right, tangent is only decreasing. That's because our A value up here, right? This A value is negative now. If it were positive, it would be going up all the time. But because it's negative, tangent's now going down all the time. Let's start by looking at our period. Okay. How does it repeat? Well, it repeats every 1 unit. Okay. There is a phase shift. So this is not actually our center, but it does repeat every 1 unit. You can pick any point at the graph to look at your period. Let's write that down. Okay, the period is 1. And I'm going to try to be consistent with my colors. Period is 1, so it's going to repeat every 1. And that makes sense because period is pi divided by b. Pi divided by pi is equal to 1. That's good. So as soon as we know that the period is equal to 1, let's go over here and make sure our step size is correct. Good, our step size is already 1 from last time, so that's helpful. Good. And now let's also look at our vertical shift. Our vertical shift is D. Our vertical shift is down 1. So let's look at that because it kind of looks weird. It looks unbalanced without looking at the vertical shift. Let's graph that vertical shift. Like before we would graph the midline, this is our middle. Okay, this is the middle of our graph. Middle used to be the x-axis, but now we can think about this as our kind of new x-axis in a sense. And now these points right here, these are the actual like middles of each tangent. Okay, and likewise, let's graph that midline. We're gonna be graphing that. It's not really, we don't usually call it a midline, but it is kind of the same thing as with sine and cosine. This line is helpful to graph. So we'll keep that on there. All right, now let's look at the asymptotes. Where are these asymptotes? Well, if the period is 1, the asymptotes are always going to happen halfway through that period. And maybe there's a phase shift. Okay. So the asymptote is going to be halfway to where it repeats. It's going to be asymptotes right here at positive 1/2. And as soon as you know where one asymptote is, just add a period, add 1 to it. That's going to give you another asymptote. Or we could have subtracted 1 to it. That's going to give us another asymptote. Okay, we only need to graph 2 periods of this function. So let's actually zoom in a little bit. We're only going to graph this piece right here and this piece. Okay, now we have a lot of the information that we need. So let's graph these lines. This kind of centering midline, in a sense, this white thing, this shows us where the middle of each tangent is. Okay, and then let's graph the asymptotes as well. All right, but before we graph things, we need to include the scale. So let's use a similar scale that we're using here. So the period is 1. Let's make, usually when you choose the scale, this is a good comment to make. Usually choose the scale relating to the period. So usually it's helpful to divide the period into 4 parts. This is a really good kind of tip for deciding your scale of your graph here. So if our period is 1, let's have 1 be 4 boxes. Okay. This means 2 is going to be over here. And -1 is going to be right there. All right. It's usually very helpful for us to do that. All right. And then if you'd like, you can graph. And again, we don't have any crazy stretching. So on our y-axis, we can still count by 1. Doesn't have to be the same as the x-axis scale. Just choose something that makes sense. Okay, so now we can graph our asymptotes and we can graph that kind of midline-esque type thing. So where are the asymptotes? They're at -0.5, +0.5, and 1.5. So the asymptotes are at 1/2, halfway between 0 and 1. 1.5, because we're just adding a period, just adding our period of 1, or subtracting our period of 1 to get all of these asymptotes. And the middle, if you will, of this graph, when you think about this middle, is this green line down here, y equals -1. And in fact, it might be even better. Let's think of that middle as yellow, because yellow is the vertical shift, and yellow is what has to do with our middle. So our function, just like always, starts at the middle. Let's plot this point. This is the point 0. Here, let's take off some of the points here. 0, -1. That's our middle here. 0, -1. And because it's periodic, it repeats every period. We also have a point here, but we're only graphing 2 periods of this function. Okay. Well, now normally it would go up 1 at a quarter of the period, halfway between the middle, and the asymptote normally goes up 1. But look at our stretching factor. So normally it'd go up 1, but because we have multiplying by -2, we're actually going down 2. Okay. Right. Normally we'd be going up 1 from the middle to get here, but we're actually going down 2. And again, you don't have to do this all by hand. Look at this point right here, halfway between the middle and the asymptote is this x value at a quarter. And at a quarter, the value is -3. Okay, so we have the 0.1 comma -3 as well. And likewise, what's halfway between the x coordinate for the middle and the asymptote over here? Well, that's going to be at -1/4. What is the y value at -1/4? +1. All right. We also have this. And again, let's use blue. And again, it's periodic. So we have the same exact thing going on in the next period. And then we just fill in the shape. So it's a steeper version of tangent, and it's going down instead. And now we've addressed everything. We have all the important information, right? The important information was the asymptotes, the middles, which have to do with these 2 points, and these points right here, halfway between the middles and the asymptotes. Okay, which normally just go up or down 1, but because of a stretching factor, that's why they went up or down 2 from this middle point, right? This is -1, this is +1. That's a difference of 2. We'll do more of these in the selected homework problems section of this section, so feel free to watch those and ask questions. This yellow line was just to help us graph it. It was just a tool. You don't have to include that yellow line, but I think it's helpful. Okay. Now, you might be asking yourself, I hope you're asking yourself, but maybe not. You might be asking yourself, Jason, we haven't talked about the phase shift. We didn't need it when we were graphing. Why didn't we need it, Jason? Well, the answer is, let's look at that. All right. What is our phase shift? Our phase shift is C over B. Our phase shift is -pi divided by pi. That's just -1. Our phase shift says, okay, take this tangent graph and move it 1 to the left. But the period is 1, which means I could move it 1 to the left, 2 to the left, 3 to the left. You wouldn't be able to tell a difference, because if I move this entire thing 1 to the left, I get this entire thing, and so on. Okay. And in fact, if we look at the graph here, watch this. I'm going to delete the phase shift. It's the same graph, right? The phase shift actually didn't do anything. Okay. Because the phase shift in this case is the period. We could add 2pi, 3pi, 4pi, 5pi. Any multiple of the period, it wouldn't change the function. All right. So if a phase shift is equal to the period or a multiple of the period, it doesn't change anything. That's the whole point of a period, right? If I move everything 1 unit to the left, well, you can't tell because it's repeating itself anyway. Okay. So that's this video. Let me know if you have any questions. And one more comment. If we wanted to identify officially the things that the homework questions asks, it talks about the stretching factor. The stretching factor is 2. It's not -2 because stretching factor is the absolute value. So here the stretching factor is 2. +2. The period, we already mentioned that, right? The period is 1 in any asymptotes. The asymptotes, right, we're at 1/2. And then every period after that. The asymptotes, they're always vertical lines, so they have to be written as x equals. Choose the first asymptote, any asymptote you want. Choose any asymptote. Right, that's any asymptote. And then you add the period, which is 1, times k. where k is any integer. This is how we're writing asymptotes. So on the homework, when it's asking, you're going to write it like this. Again, this right here is the period. And then you'll always just multiply that period by k, right? This means that an asymptote is here, but we can add 1 period, we can add 2 periods, we can add 3 periods, whatever integer k is going to be. All right. That's what this means, and that's how you write it. It'd look a little nicer if you wrote it as 1/2 plus k. You don't have to write 1 times k, but I'll accept the 1 here. It's fine. I think it's a little clearer to have the 1 there. So that's this video. Good luck. Let me know if you have questions.